Alright, good afternoon, and today this video we'll be talking about linked lists. What is a linked list? A linked list is a linear data structure that does not take up contiguous space in memory during the runtime of a program. This linear structure is formed utilizing pointers, which act as a chain links from one node to another. Due to the nature of linked lists, they can allow for the storage of different data types within its structure. Structure of a linked list. As mentioned before, a linked list is composed of a node which stores the data and a link which consists of a pointer towards the next node of the structure. Types of linked lists. Singly linked list. In this particular linked list, the node is linked via the pointer to another node, restricting traversal of the data structure in one specific direction. The final node points to a null signaling the end of the structure. Doubly linked list. In this linked list, the following nodes after the head or initial node possesses two pointers that reference the next node and the previous node. This linked list allows for the traversal in both directions. Circular linked list. The last node in the linked list possesses a pointer that references to the node at the start of the linked list rather than a null endpoint. Doubly circular linked list. A doubly circular linked list possesses the attributes of both the doubly linked list and the circular linked list. In other words, it possesses nodes that can reference the next node and the previous node, while the last node references the first node. This linked list allows the traversal in all necessary directions. Now we'll go into the application of the linked list that we just talked about. First of all, singly linked lists. These linked lists are used for implementing queues, such as the first in, first out data structure, implementing stacks, such as the last in, first out data structure, and are used for linear navigation, for example, a through list. Doubly linked list. This is used for the undo and redo capabilities, like in Word, where you make a mistake, you can undo, or you can redo what you undid. And use the forward and backward navigation as seen in text editors, just as the undo and redo capabilities. Circular linked list. This is used in systems that require a circular buffering or navigation, such as audio and video players and processing.
Okay, so to okay, so this is the code for the linked list, and our group decided to use JavaScript as our language since it's more high level. Okay, so here we have the class linked list, and in the constructor we define a head, right? So we say this.head equal null, right? So what we do here in one of the in one of the instructions that said we have to output the linked list, right? So here, this is our method of you doing the linked list, right? And also in one of the instruction, it says that we have to add to the add a value to the end of the linked list. Now this add function, what it does, it when once you add the value, it finds the last node of the list attaches and then it attaches itself to the node, right? So we also have a remove function, basically remove a value from the node, right? We also have a sort function. It's not this instruction was not a part of the main focus, but it's a cool feature that we have implemented. We also have a search where we can search for a value within the linked list, and then it will output the node, right? Also, we have the insert stat. So this basically this creates a node and attaches itself to the beginning of the list, right? So this, and then we export it as a module, right? So when we come to main, what we do, we require the linked list, and then we we defined a new linked list, right? So we say const list equals a new linked list, right? And then we say list dot add 89, right? And list, we add a few more values, right? Now, when we run this, wait, let me get rid of this. When we run this, it outputs the linked list, right? So when we say list dot insert stat, it should insert the 4 at the beginning of the list, right? Right. So here we can see 489, and then the list goes on, right? And that is how we do our linked lists. We can also, as an extension, we can see list.sort to sort the linked list, right? So the A and B value basically represents the current node and the next node, right? So say A is more than B. So if it's greater than the next node, then it's gonna sort it. When we run it, wait, before we do that, say list.print. When we run it, it should sort our node. So for the list, right, what we wanna one function, um, the other functions that was required was we have to search and also we have to remove. So if we say list dot remove, and let's say we want to remove the value 8, right? What we do when we say list dot print, we basically removing the value, right? We remove the value 8 here, right? And also, let's say we want to search for a particular value and then get the node of the value, get the node, right? We say const searched node is equal to list dot search. Let's say we want to search for the value 2, right? And then when we output it, we say console.log searched node, and we basically, when we run it, we basically get the node for the value 2, right? And yeah, and that's it. I'm gonna switch it over now.
Alright, this is all for the video. I thank you all for watching and I hope to see you all next time. Goodbye.